Okay, now this one is fun one to leave to the end, and here the numerator is of the same order as the denominator. They're both quadratics, and the thing that we said we had to do was we had to ensure that the numerator is of a lower degree. Well, it's not, so we have to do some long division to get it of a lower degree. So what we're going to do is we're going to do the division. We're going to see how many times we can squeeze the bottom one into the top one. Okay, so x squared into x squared goes once, and I'll put it over here because it's linear. Multiply this down. You should have learnt long division somewhere a long time ago. And then we just subtract. So x squared minus x squared is nothing. 3x minus negative 2x is 5x. And negative 10 take away negative 3 is negative 7. So this whole fraction that we had to start off with is exactly the same as 1 plus the remainder over the denominator, so x squared minus 2x minus 3. Okay, so the integration we're trying to do now, so the integral that we're trying to solve is equal to the integral of 1, I'm going to leave that, plus, it's actually positive 5, shouldn't it? 3 take away negative 2 is positive 5, plus 5x minus 7 over x squared minus 2x minus 3. Okay, so now I've got the situation. I mean, the 1 is easy enough to integrate, but now I've got what I want. The numerator is of a lower order than the denominator, and so it's good to go. And the next thing I need to do, step 2 on my list of steps, was to make sure this is in its prime factor. So I need to factorise the bottom line of that thing. So what have we got? We've got it's just the linear x's, and I want to have 3 and 2, and I want the negative to dominate. So it's going to be like so, dx. Okay, so now I'm at the position where I'm ready to sort this thing out in terms of partial fractions. So using my partial fractions rules from before, 5x minus 7 over x minus 3 times x plus 1 is equal to a over x minus 3 plus b over x plus 1. Multiply both sides by the bottom of the left-hand side, so I get 5x minus 7 equals the x minus 3 terms go away with the a's, plus 1 plus b lots of x minus 3, which means what have I got in terms of x's? I've got 5 on this side, and I've got a plus b on this side. And linear terms, I've got negative 7, and this side I've got x minus, a minus 3b. It's a b. Might look like a b, but it's a b. Okay, and then I can just go and sort these things out. So they're matched, so let's subtract. 5 take away negative 7 is 12. B take away negative 3b is 4b. So we learn that b has to equal 3, and if b equals 3, a is clearly 2. Okay, so going right up the top, so my original integral that I was looking at over x squared minus 2x minus 3 is equal to the integral of, where are we? We're coming to this point here. So the 1 is cool, and this fraction I can now write as the partial fraction, with a being equal to 2 and b being equal to 3. And that I can integrate quite happily. So when I've got 1 integrates to x, plus 2 lots of the natural log of x minus 3, plus 3 lots of the natural log of x plus 1. Okay, and plus c. So we've now managed to take this integration here, which doesn't look particularly pleasant at all, and work through a process to get an answer for it.